This is our next notes in Chapter 6, Lesson 6.3. We've been looking at quadrilaterals, then we looked at parallelograms, and now we're going to look at tests that we can use for parallelograms or quadrilaterals to see if they are parallelograms. And we really have 4 theorems we're going to look at. And you just want to remember, as we're going through these, each one of these shapes, we're assuming it's a quadrilateral. But then we're trying to see, is it also a parallelogram at the same time? So what are the conditions we need then? So the first one, Theorem 6.9, it says, so if this quadrilateral, if both pairs of opposite sides are congruent, then the quadrilateral is a parallelogram. So we either have to see these measurements, we have to see these ticks around here, and if this quadrilateral, if the opposite sides are congruent, then we know it's a parallelogram. And we have 6.10. So the next one are angles. So if both pairs of opposite angles are congruent, then the quadrilateral is a parallelogram. So opposite angles, right? B and D, A and C, then we know that this is a parallelogram. So here's 6.11. So this also says if the diagonals, so if we go from one angle across to the next, from A to C and B to D, it says if the diagonals bisect each other in half, then the quadrilateral is a parallelogram. So we can say if we go from A to C and B to D and they cross each other and these two are equal, A is equal to, we put this in, we'll call it P. So if AP is equal to PC and BP is equal to PD, then we know we have a parallelogram as well. Got one more here. So the next one is, so if one pair of opposite sides of a quadrilateral is both parallel and congruent, then it is a parallelogram. So they need to be the same length. They also have to be parallel. So we could have other conditions where that's not true, such as these sides. Maybe this is longer, they're still parallel. So we have to make sure they fit both conditions. So they have to be the same length, and they also have to be parallel at the same time. So those are our 4 theorems. Let's look at some examples, and then we'll be good with our notes. So a couple things here. So we look at this quadrilateral here. We're looking for a couple things. So our sides are all 4 sides congruent. That's one of the things we look for. And we might see opposite side. This is congruent. This side is congruent. So if that's true, we can also assume that they're parallel as well. And then this side, this quadrilateral would be a parallelogram. And the next one. So then here we do have opposite sides being congruent, and we have this angle. We don't necessarily know, it doesn't tell us what this angle is. Okay, so this one would not be. And we want to look at some of our rules to make sure. Okay, so this one tells us these are congruent, but these are not. So we could have these angles not be equal. Okay, and then so it doesn't fit the first one. So 6.9, both pairs of opposite sides are congruent. It doesn't say that. If both pairs of opposite angles, now we have this one, and it doesn't tell us this one. Okay, so it's not necessarily congruent, so we can't assume that. And if we look at 6.11, we don't have any diagonals on here, so we can't tell that. And then the last one, are they parallel? So they are congruent, but they're not parallel. So this doesn't fit the other one, so it's not a parallelogram. Maybe if we got some more info, we could figure out that it is, but we don't know that right now. Last thing we can do is we can use some algebra. So here we have a quadrilateral FGHJ. Let me just draw that like this. FGHJ. Just for a symbol, a rectangle there. And we know a couple things. So we know FK is equal to 3x minus 1. That's right here. This part right here. And then we know KG, this one right here, is equal to 4y plus 3, that one. And then we know JK, which is right here, is equal to 6y minus 2. And then we can take KH, and we know it's 2x plus 3. So if you in the question, it's going to say solve this so that this quadrilateral is a parallelogram. So a according to the bisector rule, if this is a parallelogram, this section here should be equal to that section. So we'll just do that. FK segment is congruent or equal to KH. So we just plug in the numbers. 3x minus 1, we'll say equals 2x plus 3. We've got to have the same variables. So then we're going to minus 2 from this side. We're going to get x. We're going to add 1 to that side. We're going to get 4. So x equals 4 for that one. And then we'll solve the other one for y. So then we're going to say KG, that segment, is congruent, right? KG is congruent with JK. We plug them in. 4y plus 3 is equal to 6y minus 2. Solve for y, right? So we'll do, let's go minus 4y, both sides. So we'll get 2y. We'll add 2 to this side is 5. Okay. Make sure we got that right. Minus 4. We're going to add 2. It's 5. And then we're going to divide by 2. So y is going to be 2.5. 2.5, or 5 over 2. So that's our answers, 2.5 and 4. Then if we go plug them in, so x is 4, so we got 3 times 4 minus 1, that's 11. We do the other one, 6 times, 2 times 4 plus 3, that's 8 plus 3 is 11. Okay, so that's true. And then we do the other one, 2.5. So we're going to go 4 times 2.5 plus 3. That's 5. It's going to be 10. It's 13. And then we'll have the next one, 6 times 2.5 minus 2. So we're going to have 2.5. It's going to be 5. It's 15. Minus 2 is 13. So then that comes out. These sections are equal to each other. So then we know we've proven that it's a parallelogram, and then we make it a parallelogram because we're making them equal to each other. And that's kind of how you solve those. Those are your notes for today. Make sure you add them to your notebook. I'll probably show you one in the coordinate plane tomorrow, how to solve that using midpoint formula and those. And just be ready in class. Keep studying for your test.